Hello everyone. We will be discussing a such particular topic which is the last portion of this chapter, chemicals, equations and reactions. That is called rancidity and corrosion. Talking about corrosion, we see in our daily life that the metals changes its texture, changes its quality due to the fact of corrosion. Why so? You must have seen, especially with irons, the iron or copper or silver, if we keep it for longer period, it normally does not remain the same. We have seen the brown flaky color or flaky substances on the iron surface if it is kept open for longer period of time. You must have also seen the presence of or the turning of copper or the presence of a green colored substance on copper. You may have seen that if we purchase one silver, it becomes tarnished after a long time. जो सिल्वर पार्टिकल्स होते हैं, जो सिल्वर के जो सब्सटेंसेस होते हैं, वो एट ए पर्टिकुलर टाइम के बाद उसका भी कलर, उसका भी शाइनी जो नेचर है धीरे धीरे चेंज होता रहता है एंड इट बिकम्स ब्लैकिश. सो व्हाट कुड बी द रीज़न? तो ये रीज़न जानने के लिए लेट अस सी वन वीडियो. Let us see that video and we will understand.
Let us face one problem to understand what it is. Let us take one aluminium toy, one iron nail, one copper pipe and one gold ring, and it is kept open in open condition for long time. So according to you, which one will be in best condition? Think of it. Pause the video and think. Okay, what's your answer? If your answer is the gold ring, then it is correct. It will be in the best condition, and copper pipe and iron nail will not at all will be in best condition, and the aluminium toy, that will also will be fairly okay, will not be disturbed. So we will find that iron nail will be in worst condition. So this is called corrosion. Why so? It is because the formation of the compounds on the surface of a metal. What kind of compounds? Means if water or water vapor or air you keep with iron, this kind of things will take place. So you see, if iron is kept in water and air, it will form iron oxides and forms the hydrated oxides also. So this is basically called the corrosion, or you can call the rusting of iron. We should remember at the same point of time that rusting, the word is only used for iron. In other cases we should call it corroded. We have said that due to reactivity the corrosion takes place. We have seen iron is more reactive than copper and of course more reactive than gold. So iron is the most reactive of the lot. But why aluminium then? Aluminium is the most reactive metal among those. So aluminium should be corroded faster, but it is not the case. This is actually aluminium is more reactive, there is no doubt about it. It reacts with the oxygen in the fastest possible manner, but it forms aluminium oxide, which is very much non-reactive or unreactive, one should say. So over the toy you can see here it forms a layer of aluminium oxide, and thereafter it does not react with anything else. That is why there is a protective layer that is being formed, and that is why it is being saved from being corroded. So in case of iron nail, how will you do this? Think of it. So iron and zinc. Zinc is more reactive than iron. So zinc obviously is going to react with oxygen to form zinc oxide, and over iron nail, if the zinc oxide, you can see the red protective layer is being formed, so it will not be reacting with the oxygen, and this is called galvanization.
So as we have understood, we have seen that two conditions. One is air, another is moisture. These two are necessary for the corrosion to happen. So in order to define a corrosion, we have written here the slow destruction of metals due to its interaction with air and moisture. Now the three major corrosion that we need to understand or need to read. First one is for iron, second one is for copper, is for silver. So we will see the basic equations that when they do interact with air and moisture, what kind of change that takes place and why. So first let us see the rusting of iron. Iron, when it reacts with aerial oxygen as well as water, it gives rise to the formation of the iron oxide along with X molecules of water. So it is observed that it is this much. So here it is 4, and how much it is? 3. And since it is 2x, so it should be 2x H2. So this is the basic equation. Here you can see, due to the formation of this is actually the rust or the brown flaky substance on the iron surface.
We already know that when iron is exposed to moist air for a long time, it acquires a coating of browny and flaky substance which is called rust. Now, in which condition iron will be rusted? To find it out, let us see one activity. So for that we will take 3 test tubes. Let us see the activity. Yes, here we will take 3 test tubes, A, B and C. In all the cases we will put 3 iron nails in each one of them. You can see the nails here. Now with the help of beaker, we'll put some water in test tube A and cork it. We'll pour boiled distilled water in test tube B and with some oil also. We are adding some oil now. Here you see we are adding some oil and we'll cork it. And in test tube C we will add some calcium chloride. The oil will float on water and prevent the air from dissolving in water. So we are putting some anhydrous calcium chloride in test tube C and we'll cork it. Anhydrous calcium chloride, what it will do? It will absorb the moisture. Now see the condition. What will happen after some time? We will observe that in test tube A, after few days, it will be corroded, means the rusting will take place. But in case of B and C, it will not be rusted at all. It will be normal. The nails will be normal. There will be no change. Why so? Here in test tube A, the iron nails are being exposed to both air and water. In B, it is exposed to only water and the air was not allowed to come in contact because of the oil present. It was floating. Oil was floating. In test tube C, calcium chloride has absorbed the moisture. So it is only touched to dry air only. The moisture was not there. So from here we can understand that iron articles rust only under the condition of air and water both.
Let us see the rusting of iron in little bit more details. See, iron can obviously lose 2 electrons to become Fe2 plus 2 electron. See, I am telling you once again, this is a little bit detailed discussion. Whatever reaction that I have written, that is sufficient enough. But if you want to have further knowledge, see to it. So it becomes Fe2 plus 2 electron. At the same point of time, in presence of the oxygen, that is O2, which is a good oxidizing agent, it can further lose more electron to become this much. So it is 4Fe2 plus 4Fe3 plus. So 1 electron change per iron, it becomes 4 electron. Now oxygen is having the capability that in presence of water as well as this 4 electron, it can give rise to the formation of hydroxide ions, that is 4OH minus. So just to balance it, we will write it as 2. So initially this happens. Then as the hydroxide is also there, Fe2 plus and Fe3 plus is also there, these two will combine. So how do they combine? Fe2 plus combines with 2OH minus to give rise to FeOH whole twice. Similarly, Fe3 plus will also combine with 3OH minus to give rise to FeOH whole thrice. After this, when the hydroxides are formed, here you see, when the hydroxides are formed already, they can be dissociated into Fe2O3 plus water. They can be dehydrated, rather, we should say. And, sorry, this one should be for ferrous, and for ferric, we should be writing Fe2O3 plus H2O. In order to balance it, we should write this and 3. So, we have observed that the formation of these two oxides, here it is in +2 state, here the iron is in +3 state. So, due to the presence of these two oxides from iron, ultimately the rusting takes place. So, the equation that we have written earlier was a simplified one. This is a comparatively detailed study. This is the details about the rusting of iron. So, you note it down and try to write it over and over again so that you can remember this and understand. After observing iron, we are going to see the corrosion of copper. We have seen that the house where the roofs are made up by copper, if that is there in the roof, if the copper is present, if it is exposed for a longer period of time, we have seen the color becomes greenish. तो उन लोग जो घरों का छत जो है उसका कलर थोड़ा सा चेंज हो जाता है in those cases. That means there has been some kind of corrosion. We can see that effect on Statue of Liberty also. So what is the reason? The reason is this one, that copper, when it comes in contact with real oxygen, carbon dioxide, as well as water, it gives rise to the formation of this compound, CuCO3, along with CuOH whole twice. This remains together and it will be 2, and this particular compound, this is a base, of course. This is actually green in color. Actually it is green. So this is called the basic copper carbonate, due to which the copper converts into a greenish appearance. It appears to be green in front of us. So this is how the corrosion of copper takes place. Let us see the case of silver then. The ornaments of silver, whoever has purchased, he must have observed, he or she must have observed that after some period of time, it becomes, the shininess, the shine of the silver changes. It becomes a little bit grayish, the color tarnishes. तो जो कलर जो है थोड़ा सा चेंज हो जाता है, शाइनी जो अपीयरेंस है that becomes not so shiny anymore. What could be the reason? The reason is this one, that silver, when it comes in contact with oxygen, it can form Ag2, right? And at the same point of time, Ag2O, when it comes in contact with H2S, which is present in air, of course, it forms H2S. When it reacts with Ag2O, it forms Ag2S plus H2O. Now, this is grayish, or you can say black in color. Black I'm writing. That is why this one will become a surface on the silver, and it becomes, it appears to be black in front of us. Now we need to understand that the tendency of combining of oxygen is lesser than that of sulfur in case of silver. That is why silver sulfide is formed. Same thing has been written in some of the books as Ag plus S giving rise to, Ag2S. That is also okay. Sulfur is present from air itself. Now, once the blackish appearance is there already, can we change it? Can we regain the color? The answer is yes. How to get this? It is regaining of shiny appearance on silver. Let us see. So we can take a toothpaste actually. So in the toothpaste, little amount of hydrogen peroxide is present, very little amount though. What hydrogen peroxide can do on dissociation, it can give rise to the formation of H2O plus nascent oxygen, this one. Newly formed oxygen, much more reactive of course. And that nascent oxygen actually is having the capability to react with the silver sulfide which is already formed, and it will give rise to the formation of Ag2SO4. This is actually white, this one. So this was black, and this is white. What will be the full equation? So we know that there are 4 oxygen, so it should be multiplied by 4. So in order to maintain this, I am rewriting this equation here. It should be, in order to find out the actual equation, because here it involves H2O2 and Ag2S. Nascent oxygen you cannot see it directly not involved. It is formed during the reaction and there only it reacts. So it gives rise to H2O plus aerial oxygen, nascent oxygen, sorry. So if it is multiplied by 4, I need 4 oxygen from here, so everything will be multiplied by 4. Now cancel these two. It gives rise to the formation of Ag2S plus 4 H2O2 giving rise to, here it is, Ag2SO4 plus 4 H2O. Remember once again, this one was black, the color which appears due to the corrosion of silver, and this one becomes white, so we can regain the shiny appearance. This is how it is.
So there are various ways of prevention of corrosion, especially in case of iron. We have to read it in details. So these are the processes. You note it down. It is painting, oiling, greasing. So just the idea is to keep a layer on the iron surface so that directly doesn't come with the moisture or air. Then there is galvanization. Chrome plating, here it is, chrome plating. So these are the processes, out of which most of them are known. Preparation of alloys also is one of the most well-known processes, to just to combine two metals to form an alloy so that the rust will not be formed. So here it is, alloys. So among the following, galvanization process is the most well-known process and one of the best processes. It is a method of protecting steel and iron from rusting by coating them with a thin layer of zinc. We know that zinc is more reactive, so if zinc is there, it will react and will form a protection over the iron surface, and this is known as the galvanization. This can also be done by the electrolytic method, so then it is known as the electroplating of zinc. After corrosion, let us pay our attention to rancidity. What is rancidity? It is the oxidation of oils and fats in food, resulting in a bad smell or taste. We have seen in our daily life that if the foods are kept open for a longer period, it becomes rancid. So what is the process that is written over here? You also note it down. So what happens is, if the food is containing fat, it combines with oxygen and oxidation takes place. So it's a chemical process basically. Rancidity is a chemical process. This question can come, so be careful. So fat, when combines with oxygen, it spoils, means it is not edible anymore. So how to prevent? Using antioxidants, which will stop the oxidation process, which will not allow the oxygen to react with the fat that is present in the food. Vitamin C is one of the very good example of it. So that we can do by adding antioxidants. Then the refrigeration is another technique, means to keep it in lesser temperature. What happens is, if the low temperature is there, then oxidation process slows down, because in order to oxidize, you need to have these two conditions. One is humidity and another is the warm atmosphere. So if it is kept in low temperature in refrigeration, oxidation will be stopped. Then the vacuum packing, as we can see in the packet of Lay's and all, the lesser number of chips but more amount of vacuum is there. And remember, in the vacuum spaces, the air is there. Air is not oxygen basically. The nitrogen is kept over there because it is a non-reactive gas, and it will prevent the chips to come in contact with the oxygen and to get